Question 10, the last question on this test. And at first it looks like a geometry type question, like what's going on. If you scroll down a little bit, you kind of see they're talking about indefinitely. They have like a list here. It looks like it's actually a sequence question. It's an algebra question, just done in a super fancy way. So let's dive into this. The sides of a square are 16 in length. So you can see 16, 16, 16, 16. The midpoints of the sides of the square are joined to form a new square and 4 triangles. So kind of see that picture there? Notice how they say this is a midpoint. So this is 8 and 8. It's an isosceles triangle right here. The process is repeated twice as shown in diagrams 2 and 3. So this kept on doing that. So right here, like these are the same, these are the same, and you get these like new triangles. Let xn denote the length of one side of the equal new triangle. So there's xn, there's x1 right there, 8. x2 would be like this guy. That would be x2. x3 would be like this guy. Let an denote the area of each new triangle. So that's the area, a1 there, a2 there, a3 right there. Do the following table and given the values, copy and complete the table, do not write on this page. So they want us to find xn. They already did the first one for us. They did x1. They want to find x2. Okay, so let's look at what we have. We know this is 8. We know this is 8. And we know this is a right angle. So this is an isosceles triangle. So, or also known as a 45-45-90 triangle. So we can find the hypotenuse. All we gotta do is a squared, b squared, c squared. That's my attempt at a straight line. So we're gonna do a squared plus b squared equals c squared. I'm gonna get 64 plus 64 equals c squared. 128 equals c squared. Square root of 128 equals c. Probably have to break that down. A good way to break it down is 64 times 2 because we just did that. Square root of 64 is 8, so 8 rad 2. So that's one way to do it. Also, an easier way of doing it is if you know your 45-49 triangles, it's always x rad 2. So this whole line is 8 rad 2. So that's probably the fastest way of doing it. But before we get ahead of ourselves, notice the side I want is not the whole length. It's only half of it. So it's 8 rad 2, I got to divide that by 2. I'm going to get 4 rad 2. That's the length of the side right there. This right here is 4 rad 2. Because it's half the hypotenuse. So you get that. Now they want us to find the area. So the first area to us is 32. That makes sense, right? Area of a triangle is just 1/2 base times height. And then this is 8 times 8, which is 64. Half of 64 is 32. Then they're saying the area of this one is 16. We could try that ourselves, but I'm sure we'll get 16. And it wants to find this one. So you have two choices. You can actually figure out what that is and do it. Or, if you notice the pattern, it's 32 divided by 2 is 16. So divide this by 2, and you get 8. So that's the pattern. 8, 4 rad 2, 4, 32, 16, 8. The process described above is repeated to find A6. Okay, so they want us to find A6. So if we had a 4 here, who cares what this is going to be? All I want to find is the A's. This would be half of that, which is 4. Have a 5, would be half of that, which is 2. Have a 6, would be half of that, which is 1. So A6 is just 1. Consider the initial square of side length k. The process described above is repeated indefinitely. So right there, when they say indefinitely, you know you're going to do an infinite sum formula, which is this guy. The total area of the shaded regions is k. Find the value of k. So they told us all this equals k. So all I gotta do is fill out this formula right there for the areas. Now I know something else. I know what r is already. We figured it out. It's 1/2. We're dividing by 2 every single time. So r is just 1/2. All I gotta do is figure out what a1 is. And a1 is the area of the first triangle. This right there. Now I can't just use 32 because remember this time they're doing with the side length of k. So let's draw that out. They're giving us this and that thing like that. They want us to find this area here when this length is k. So that means that this guy is half of k. And if I want the area of this thing right there, it's going to be 1/2 base times height, or 1/2 half of k times half of k. So I get 1/8 k squared. That is the area of the first one. That is my A1, 1/8 k squared. So let's plug this all in, right? They said the infinite sum, which is this formula right here, equals k. So I said equal to k, and then I plugged stuff in. I plugged this in for A1. I plugged the r we found right here. We're dividing by 2 every single time for my r. So if I rewrite it, I'm going to get this. 1/8 k squared over 1 minus 1/2 equals k. Let's do some math. 1/8 k squared over 1/2 equals k. I want to get rid of that 1/2, so multiply both sides by. Now a lot of people multiply by 2. That doesn't cancel out 1/2. Multiplying by 1/2 cancels out 1/2 on the bottom. That's how you cancel out 1/2. You're being divided by, you multiply by the reciprocal. So I get 1/2 k. Right? So 1/2 was on the bottom, I multiply by 1/2 to get rid of it. And then here, in this case, let's get rid of the 1/8. So I'm gonna multiply both sides by 8. And I get k squared equals 4k. So now we just gotta solve this. Remember, the way you solve something when it's squared or higher, you set it equal to 0. So move this guy over. I'm gonna get k squared minus 4k equals 0. I'm gonna factor out a k. I'm gonna split and solve. K equals 0. K minus 4 equals 0. So k equals 0 and 4. K equals 0 doesn't make any sense, right? We're doing the side length of a square, so that's not going to work. So my answer is just going to be k equals 4. And that was the final problem.